My name is Sid Parker, and today I'm going to be telling you a little bit about the baconian cipher. So it was invented by Francis Bacon. He was born January 2nd in 1561. His mother was a scholar and also a translator, so she wanted him to be very educated, which he did. He went to Cambridge from the age of 12, where he studied Latin and geometry, grammar, music theory, logic, and rhetoric. He also had a lot of great achievements. His most famous achievement was actually not for making the cipher, but for his achievements in science. But, at that time, most scholars' arguments were based on logic and philosophy, whereas he introduced the idea that it should be based on observations and experiments. So a couple of other achievements were he was a member of the parliament at age 20. He became knighted by for his service to King James at the age of 42, and he was appointed as England's Attorney General at age 55. And he became the Lord High Chancellor, which he lost his position very quickly because he took a bribe. And then he eventually passed away from pneumonia at age 65. So Bacon's code is a bilateral substitution alphabet, which it takes groups of 5 letters, and it's very similar to binary code, where you've got 1s and 0s, or in this case, A's and B's, and they each stand for a letter, which the U and the V share the same code, as well as the J and the I. So then this is just the all the codes for each letter, pretty much. So, for example, let's take that code right there, BAAAA, which translates to R. So, how it works, how computers also sort of read it too. Starting from the last letter to the first letter, you're going to take 2 to the power of, starting from 0, 1, 2, 3, 4. And generally, binary numbers on the computer have 7 numbers because they like to include like symbols and exclamation whatever. So you just continue that with 2 to the power of 5, 2 to the power of 6, etc. And so what you do is you only take the B, or what would be the 1, and you take 2 to the power of 4, and that's 16, which, because we start off at A is 0, so B would be 1, C would be 2, so R, instead of being 17 like it is in the alphabet, how you normally count it, it's actually 16. So, let's encode something. So, for example, our secret message is going to be rabbit. So, I have up here all of the codes for each letter. And so what you're going to do is you're going to make a sentence, a completely random sentence that's not related to anything. Or it can be, I guess it doesn't really matter, but you're using the sentence to hide your code. So because we have a 6-letter code, and each letter is 5, so you want your sentence to be made up of 30 letters. So, for example, let's encrypt. Do you want to go to the movies Sunday? So, the corresponding code with spaced out appropriately to the sentence is going to be this nice long BAA whatever over here. So what you're going to do is you're going to capitalize where all the B's are in your sentence. So there's a B in the first part of this, as well as your sentence that you're using here. And it doesn't have to be capitalization. It can be, you can change the color of the letter, you can do like a tiny dot above the letter, it doesn't matter, as long as there's some sort of way to differentiate between the letters. So to decode, it's really, really simple. If you know what to look for, you're going to just take the off-looking letter, and so the off-looking letter is going to be your B, so it's going to be AA, BA, which goes for the C. And you just go through that through the entire sentence. So it's really easy to crack this code. If you know what to look for, you basically got it. So, there are a couple ways you can sort of hide it better. One of the things you can do is change all the letters so it's just harder to read. You just got to make sure the person you're sending the message to sort of knows which letter is the right one. But again, trial and error. This is pretty easy to crack. And here are a couple of my references. Thank you for your time. Anybody have any questions?